Now on problem 37. And they say, what is the value of xy minus yz? Minus yz. Statement 1 says y is equal to 2. Well, that by itself doesn't help us. That just tells us 2x minus 2z. So if you don't know what x and z are, you can't figure out what this whole thing is if you just know y is equal to 2. So that alone doesn't help. Statement 2 is x minus z is equal to 5. X minus z is equal to 5. Now this is interesting, because this expression we can factor out the y. What happens if we factor out of y of both of these expressions? Let me just rewrite it. xy minus zy. I just switched the y and the z. That equals x minus z times y. Well, we can figure out x minus z from statement number 2. X minus z, this is equal to 5. And we know what y is equal from statement 1. So y is equal to 2. So we can definitely figure it out as long as we have both statements, and we can show that the answer is, well, y is equal to 2. So the answer is 2 times 5 is 10. But we didn't have to figure it out. We just had to know that we could figure it out if we had both of these data points. One by themselves, you wouldn't be able to solve it. So the answer is C. Both statements together are sufficient, but neither alone is. Problem 38. Okay, they drew us a picture. Let me see if I can draw that same picture. Looks like some type of device. So it looks like that. Then they have the other end. The other end looks like that. And there's these handles, or something that looks like handle. I haven't read the problem yet. So they say, with the first 10 volumes of a 20-volume encyclopedia fit upright in the book rack shown above. So there's a book rack, so I guess the books get stacked that way. And they labeled this right here, this dimension is x. And they're saying, will the first 10 volumes of a 20-volume encyclopedia fit upright in the book rack shown above? So essentially, I'm going to put the first 10 in there. So the first statement they say is that x is equal to 50 centimeters. Well, that doesn't help me because I don't know how big the first 10 volumes of the encyclopedia are. If each of them are, at least the first 10 are less than 5 centimeters each, or on average less than 5 centimeters, then maybe I could fit them. But one by itself doesn't help me. 2. 12 of the volumes have an average thickness of 5 centimeters. 12 have average of 5. Well, that doesn't help me either, because remember, they're saying, well, the first 10 volumes of a 20-volume encyclopedia. Maybe the 12 that have an average thickness of 5 centimeters, maybe those are the, volumes 8 through 20. And maybe volumes 1 through 7 have an average thickness of 50 centimeters each, or 5 million centimeters each. So even both of these conditions combined don't help me know if I can definitely fit the first 10 volumes of the 20-volume encyclopedia. So that is E. Both statements together are still not sufficient. Problem 39. A circular tub. Okay, so they've drawn this circular-looking tub. So the top looks like that. And then there's two sides. Let me see how well I can construct what they've drawn. And the bottom looks something like that. And then they shade in a little area, a strip of this, like that. And they say a circular tub has a band painted around its circumference as shown above. So this is the painted band around its circumference. What is the surface area of the painted band? And they tell us that the height of the painted band is x. So in order to essentially know the surface area, you would have to know the height, which is x, times the circumference of the circle, right? Which would be the length. So if you knew the height times the circumference of the circle, you'd be able to know the surface area. So they tell us the first statement, x is equal to 0.5 whatever, meters. So this is in meters. 0.5 meters. So that alone doesn't help us. We have to be able to figure out the circumference of this tub in order to really be able to figure out the surface area, because the circumference times its height will be the surface area. Point 2, they say the height of the tub is 1 meter. So they are telling us that this is 1 meter. Well, that doesn't help us. That still doesn't tell us how far around the tub goes. If they had given us the diameter or the radius or the circumference, then we could have used our basic geometry to figure out the circumference. But they didn't. So either way, so 1 meter height, both of these combined still do not allow us to figure out the surface area of this green band. E again. Problem 40. What is the value of integer n? And n is an integer. So statement number 1, they tell us that n times n plus 1 is equal to 6. Now, we should already be able to figure this out because n is an integer, n plus 1 is an integer. So so what are the factorizations of 6? You could have 1 times 6. But that doesn't fit n and n plus 1, right? This is n and n plus 5. You have 2 times 3, which work, right? If 2 is n, n plus 1 is 3, and they equal 6. So let me circle that. And then what other factorizations? You don't have any other. 4 times. So these are all of the factors of 6. And so just looking at the first statement, you know that n has to be equal to 2. This is the only integer where this is true. Actually, let me take a step back. No, what if n is negative? Because I was assuming it's a positive integer, but they didn't say it's a positive integer. So let me think about that. If I did minus 3 times minus 2, that also equals 6. And these are both integers. Okay, so this isn't enough. Because in this case, because this would be n and this would be n plus 1. So n is either equal to 2 or n is equal to minus 3. That's a little tricky. The intuition is to just assume that n is positive, but it doesn't have to be positive. So n could be 2 or minus 3 here. That's a tricky one. So that 1 by itself does not help us solve the problem. The second part of it, point 2, it says 2 to the 2n is equal to 16. And whenever you have these, whether you're taking the SAT or the GMAT or anything, whenever you have a variable in the exponent, your goal really is to just get everything in the same base. So we could write the left-hand side the same. So that's 2 to the 2n. And how do we write 16 with the base 2? Well, 16 is just 2 to the 4th, right? 2 to the 4th. And so we get 2n is equal to 4. N is equal to 2. So this statement alone is enough to figure it out. This statement alone is not. So the answer is B. I always have to review what the statement. B. Statement 2 alone is sufficient. 40 is B. And this was tricky because 1, you think that 1 alone is sufficient, but it is ambiguous because n could be minus 3. 41. 41. Okay. They've drawn a bunch of, if I see this right, they've drawn a bunch, 2 lines. Let's see if I can draw this. It's a line, and then they have a bunch of circles. One circle, 2 circles they have, and then they keep going. Let me see. 3 circles, and then 1 more. It's going to be like right there. 4 circles, I think that's about right. And then they say essentially that the circles just keep going on and on. That's what I think the drawing implies. And they say the inside of a rectangular carton is 48 centimeters long. So the inside of a rectangular carton is 48 centimeters long, 32 centimeters wide. So 32 centimeters wide. This is an 8. 32 centimeters wide and 15 centimeters high. 15 centimeters high. Okay, so that's the inside. Kind of if we're reviewing from the other wall, this is the floor of the inside of the container. And then there'd be another up here. But I think you get the idea. The carton is filled to capacity with K identical cylindrical cans of fruit that stand upright in rows and columns as indicated in the figure above. Okay, so this is like a top view of it. So we could say that this side up here, this is the top, this is 48, and then this is 32. So we don't care so much about the height, I think. So let's see. The carton is filled to capacity with k identical cylindrical cans of fruit that stand upright in rows and columns as indicated in the figure above. If the cans are 15 centimeters high, okay, so each of the cans are exactly 15 centimeters high. So they literally are as exactly high as the carton. If the cans are 15 centimeters high, what is the value of k? So we have to figure out how many will fit. How many of these cans will fit in this in this area, essentially? And they tell us, point number 1. Each of the cans have a radius of 4 centimeters. Radius is 4 centimeters. Well, if we know that each of them have a radius of 4 centimeters, then we know exactly how much square area each of these circles will take up, assuming that they're packed exactly like this, right? Because if you think about it, what is this area right here? Well, there's a bunch of different ways you could think about it. Well, the easiest is that if the radius is 4 centimeters, the diameter right here is 8 centimeters. So if this is 8 and you have a 48 length, you can only do 6 of these. All right, 6 times 8 is 48. So you can only do 6 that way. And then if the diameter is 8 this way, and this length is 32, you can only do 4 this way. So statement number 1 alone is enough to figure out how many you can put. It would actually be 4 times 6. You could put 24. K would be 24 cans that you could fit in. So statement 1 alone is enough. Now what does statement 2 tell us? 6 of the cans fit exactly along the length of the carton. 6 of the cans fit exactly along the length of the carton. So they're telling us that these cans, there are 6 cans that fit right along the length, which we figured out from statement number 1. But that also gives you the same information as statement number 1, because you know that these are cylindrical cans. I guess we can assume, I think it's a safe assumption to say that these are circles, although they haven't, a cylinder, you're assuming that the tops are circles. So if you say that 6 can fit that way, then you know that the diameter of each of them is 8 centimeters, and then you can make the same argument that the diameter is 8 centimeters to say that 4 can fit the other way down. So 2 alone is also sufficient by itself. So the answer is, what is that? C. Both statements, no, D. Each statement alone is sufficient. See you in the next video.